In this example, we're given some information about a particle. It starts from some point A and moves along a straight line, so back and forth on some straight line. Its velocity after t seconds is given by this nice equation from 0 to 4, which is graphed out here. The particle is at rest when t is equal to pi over 2. So let's put that on there. Velocity is 0 here when you have time pi over 2. All right? The following diagram shows the velocity. The task is to find the distance traveled by the particle. So we know that distance traveled is the area under the velocity curve. So the first thing we can do is go to Math menu. We're going to integrate. We're going to integrate from 0 to the value of pi over 2. The function is e to the power of a half. I'm just going to put in 0.5 cosine of x. And now you got to scroll over to the right and subtract 1 with respect to x. I don't know why, but a lot of people miss the subtract 1 for some odd reason. Okay, so when you enter this value, you get 0. The distance traveled is 0.614, and we have meters. Explain. These ones are a little bit more conceptual. They take a little bit more work. But let's look. We've also got 4 points here. So it's simply saying because the particle goes back and forth, it won't be nearly enough. The area here underneath the curve indicates the distance traveled, but it's negative velocity. So there's a direction change here. Direction change. So let's put, since at pi over 2, there is a direction change. Okay, that's part of it. Now, why the particle passes through A again, it starts at A with a certain velocity. It's moving in a positive direction along the line. Then it switches, and it's going to start, instead of going this way, it's going to start going that way. But here, we want to know that we've gone even further. So this red area should exceed this blue area. So we should prove this from pi over 2 to 4. This is 4 points, so this won't be enough. We need to show that this red area exceeds 0.614. So of the function, let's see if we can be efficient here. It's given as v of t. That's great. So then we can go v with respect to t. Right? So second enter, bring this function back rather than retyping it all again. Now our lower bound, though, is going to be pi over 2. And our upper bound is going to be, the upper bound is going to be 4. Okay. So this value here is 0.719564, blah, blah, blah. Okay. And negative. So since, so this is the particle must pass through A again. Okay. So if you want to think about that with the number line here again, right? So if we started at A and we go here, the distance would have been 0.614. Now we're going to start heading back in this direction, right? And well, I probably should have used blue for this line. That would have been more clever. So this corresponds to this blue area, and then the red distance here is going this way, and that was 0.71956. So this obviously has passed through A again.